KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class we are going to discuss 2 example problems. Afterwards, you can continue with the continuation topic. Okay ma? See here. So first we will discuss first example problem. First example problem means first example problem in this class. Okay, right. So that is example 5.10 in this chapter, right? So 5.10. Okay. Concentrate here. You need to concentrate more because in our previous class we discussed motion on a banked road, motion of a car on a banked road. So related to that concept, now we are going to discuss some problems. Okay, right. So related to the topic, we are going to discuss some problems. So you please be concentrate. In our physics, first concept and problems based on the concept helps us to understand deeper. See here. First example problem. In this class, say this na. A cyclist speeding at 18 kilometers per hour on a level road takes a sharp circular turn of radius 3 meters without reducing the speed. Without reducing the speed. Full stop. The coefficient of static friction between the tires and road is 0.1. Question is, will the cyclist slip while taking the turn? Will the cyclist slip while taking the turn? This is the question. Okay, right. Now, if you see that problem, in that problem they have given some values and asking, will the cyclist slip while taking the turn based on these values? Okay, right. So, from our previous discussion, on an unbanked road, frictional force alone can provide the centripetal force needed to keep the cyclist moving in a circular turn without slipping. Right? So I am saying one point from our previous discussion. That point is on an unbanked road, frictional force alone can provide the centripetal force needed to keep the cyclist moving on a circular turn without slipping. Right? So on an unbanked road, to take the turning or to complete the circular turn without slipping, we need centripetal force. That centripetal force provided by the frictional force alone on an unbanked road. Now, if the speed is too large, right? So here speed means speed of the cyclist. If the speed is too large or if turn is too sharp, whatever it may be, if the speed is too large, speed of a cyclist is too large, too large. If the speed of the cyclist is too large or the turn is too sharp, then the frictional force is not sufficient to provide the necessary centripetal force and the cyclist slips, right, and the cyclist slips. So first point is, on an unbanked road, the centripetal force needed to complete the circular turn for a cyclist will provide by frictional force alone. Second point is, if the speed is too large or if the circular turn is too sharp, the frictional force, right, the frictional force is not sufficient to provide the necessary centripetal force, then automatically the cyclist or the cycle slips, the cyclist will fall down. Okay, right. Now we are going to check, will the cyclist slip while taking the turn with these values, with these quantities. Okay, right. See here, this is the condition, for the cyclist not to slip, that is v square is less than or equal to mu s or g. Now r is equal to 3 meters, g is equal to 9.8 meter per second square, mu s is equal to 0.1. Now mu s r g is equal to 2.94 meter square per second square. So mathematically you substitute the given values and then you calculate. So it is a multiplication, it will give us 2.94 meter square per second square. Okay, afterwards, but according to the given, it is v square, it is not v, it is v square. See this, it is v square. Okay, but according to the given, v is equal to 18 kilometers per hour. So if we convert 18 kilometers per hour into meters per second, then it is 5 meters per second. Okay, now v square is equal to 25 meter square per second square. So according to the given values, v square is 2.94 meter square per second square, but he has given himself v square is equal to 25 meter square per second square, but there is no matching, no. So this is the speed to avoid slipping, but this is the speed with which he is moving. This is the speed, means we calculated v square, speed is 5 meters per second only. To compare this, we calculated and we took v square, that is the only difference. Okay, right. So because of there is a lot of difference, it is almost like 5 meters per second, and if you take that, it will be nearly 1.7 something. Okay, so that's why there is a lot of gap. So that what is the answer? The cyclist will slip. The cyclist will slip while taking the circular turn. Okay, that is. So here the answer is cyclist will slip when he is taking a circular turn. Right. Next example problem. Example 5.11. Example 5.11. Okay, right. See this, ma. A circular race track of radius 300 meters is banked at an angle of 15 degrees. Full stop. If the coefficient of friction between the wheels of race car and the road is 0.2. Now he is asking to find something. So what is the optimum speed of the race car to avoid wear and tear on its tires, and B is maximum permissible speed to avoid slipping. Maximum permissible speed to avoid slipping. Okay, so he has given radius of the circular track, angle of banking, coefficient of friction between the wheels of race car and the road, asking to find V naught and V maximum. V naught and V maximum. Okay, right. Now we are going to see the solution. Right. See here, on a banked road. So in our last class, in our previous class, On a banked road, the horizontal component of the normal force and the frictional force contribute to provide centripetal force to keep the car moving on a circular turn without slipping. So, from our previous class discussion, now I am saying one important point, that is, on a banked road, the horizontal component of the normal force, right, and the frictional force contribute to provide centripetal force, which helps the car when the car is taking a turn without slipping, okay, right. Next, at the optimum speed, the normal reactions component is enough to provide the needed centripetal force. At optimum speed, the normal reactions component is enough to provide the needed centripetal force. But in first sentence, in first line, what I told ma, there component of the normal force and frictional force both are needed to provide centripetal force, which helps the car to avoid slipping. But when it is moving with optimum speed, what I am saying, normal component is enough. That is what the component of normal force is enough to provide the needed centripetal force, right? And the frictional force is not needed. This is the situation on a banked road when the vehicle is not moving with optimum speed and when the vehicle is moving with optimum speed. Okay, so please try to understand what the two important points I told before entering into the solution. See here, the formula for optimum speed, V naught is equal to, actually it is square root of Rg tan theta, but you can write like this, Rg tan theta whole power 1 by 2, right? So the values they have given R is equal to 300 meters, theta is equal to 15 degrees and G is equal to 9.8 meter per second square. Okay, so now we have to substitute all these values to find V naught. So already formula is given now. So R value, G value and tan theta value all are in SI now. So no problem, directly you can substitute. After completion of mathematical calculation, you will get it as V naught is equal to 28.1 meter per second. And next it is A. Next B is, he is asking to find maximum permissible speed. That is, the formula is V maximum is equal to Rg into mu s plus tan theta divided by 1 minus mu s tan theta, whole power 1 by 2, that is equal to 38.1 meter per second, 38.1 meter per second. Okay, that is the maximum permissible speed. B, according to the question, one is A, that is he is asking to find optimum speed of the race car, and next B, okay, that is what maximum permissible speed. So optimum speed is 28.1 meter per second and maximum permissible speed is 38.1 meter per second. 38.1 meter per second. So if you see that A, he clearly mentioned optimum speed of the race car to avoid wear and tear. In this condition, the frictional force is not needed, only the normal component of force, right? So that is what component of normal force is providing centripetal force, right? Okay. Next, our next continuation topic is solving problems in mechanics. Okay, right. So in this oldest and important branch of physics, that is what mechanics, we need to solve the problems, many more problems, right? But while solving the problems related to mechanics, force is the important component. force is the important quantity also. Okay, right. So when you are talking about force, as we discussed previously in our previous classes, whether the concept or for problems, we split the force according to the angle. It is what horizontal component and vertical component, and we checked the forces are balanced or not. Suppose if the forces are balanced, based on the given situation, we took it as one part. For example, the forces acting along the x-axis, the forces acting along the y-axis, the forces acting along the z-axis, like that. Okay. So when we are going to deal the problems in mechanics, force is the very important thing. Okay. So that's why here I am going to give. So we are going to discuss some steps which helps us while solving the problems related to mechanics. Okay. See here, ma. See here, observe carefully. I will tell you there are 5 rules. There are 5 steps. Okay. Instead of rule, it is better to call as steps. There are 5 rules. So here I have written 3 steps. There are 5 steps. Sorry, there are 5 steps, but here I have written 3 steps. Remaining 2 steps we will discuss in the coming class. But before entering into the steps, I will tell you some information why we need all these steps. Okay, see here. So you know very well, in our physics, right, we are in a discussion about, already we discussed. So in this chapter, laws of motion, already we discussed Newton's laws. Newton's first law, Newton's second law, and Newton's third law, right? So what is Newton's first law? Every body in this universe continues its state of rest or of uniform motion unless some external force applied on it. Second, Newton's second law of motion is, right, rate of change of moment. So the external force, Newton's second law, the external force applied on a body is directly proportional to the rate of change of momentum, right? So you can also write F is equal to ma. Afterwards, Newton's third law is, for every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction. These 3 are the Newton's 3 laws. When we are dealing a problem which includes Newton's laws, right? So as I told already, force is the important quantity here. We need to split the force according to, along x-axis and y-axis. At that moment, these 5 steps what I am going to discuss to you helps a lot. Okay. See here. So the 3 laws of motion that we have learned in this chapter are the foundation of mechanics. Next, we should know, right? We should know it is able to handle a large variety of problems in mechanics. Okay. So we need to solve, we need to answer for a large variety of problems in mechanics. Okay. A typical problem in mechanics usually does not only involve a single body under the action of a given forces. So in one problem related to mechanics, we can't expect a single body. For example, a person is pulling certain amount of mass. So here person is one of the thing and mass is one of the thing. So here 2 things are involved. Okay. So here you have to know the forces acting on the person, you have to know the forces acting on the mass, right? So that's why he told a typical problem not only involved a single body. Next, more often we will need to consider an assembly of different bodies exerting forces on each other. So just now I told you, a person is pulling certain amount of mass. So here you need to consider both the bodies, the person and the mass. Then only you can solve the problem. Okay, right. Afterwards, each body in the assembly. So here assembly means actually person plus mass. Otherwise you can take separately also or individually also, right? So when you are taking each body in the assembly, experience the force of gravity. It is the primary force. So every time I used to say, in this entire universe, the first or the initial force which acts is gravitational force, because whenever there is mass, the first and foremost force is gravitational force, right? It is force of gravity. Next, when you are trying to solve a problem related to mechanics, it is useful to remember that fact that you can choose any part of the assembly and applies the laws of motion to the part provided, and by including all the forces on the chosen part due to the remaining parts of the assembly. So I am going again to the same example. A person is pulling certain amount of mass. When a person is pulling certain amount of mass, either towards him or away from him, so either he is pulling or pushing. Here you can see the two things separately, or by taking two things as a one system, and by taking a person as a separate, and by taking the mass as a separate. So in different aspects, we have to know the forces acting on a person or mass or both. Okay, right. So that's why chosen part of the assembly as the system and the remaining part of the assembly as the environment. For example, you are taking the person as a system. Now the mass is the part of surroundings. Suppose you are taking mass as a system. Now person is the part of surroundings. Okay. Now see this. So in that manner, what I am saying is here. So how to solve the problem? How to solve such type of problems? Okay. Right. So now 5 steps will be discussed. These 5 steps you have to memorize and you have to apply. Physics means application is very important, no? So not only memorizing, first you have to memorize and then you have to apply to solve a mechanical problem. Okay, right. So the first step is draw a diagram showing schematically the various parts of the assembly of bodies, the links, supports, etc. Right? For example, a person is pulling certain amount of mass. So there is a connection now, maybe a rope. So rope is the link here. So what he is saying, draw a diagram showing schematically the various parts of the assembly of bodies, the links, supports, etc. Suppose still now from the starting of this topic solving problems in mechanics, I took only one example, that is a person is pulling certain amount of mass. Okay. Otherwise now I am going for another example, that is what, a monkey is hanging to the tree, right? A monkey is hanging to the tree. So there the branch is there now. So the branch which is going to handle, which is going to catch, which helps monkey to hang. Okay, that is what the suspending, like hanging. Okay, so here, so whatever the link which is there, that also you have to consider into the problem. Next, choose the convenient part of the assembly as one system. So this I already told you, whether the person or a mass, whatever you want, you can take it as one system. Okay. Next, draw a separate diagram which shows this system and all the forces on the system by the remaining part of the assembly. Right? Draw a separate diagram which shows this system and all the forces on the system by the remaining part of the assembly. So this is the important point in third step. Next, include also the forces on the system by other agencies. Do not include the forces on the environment by the system. And a diagram of this type is known as a free body diagram. Okay, right. For example, a person is standing here and there is some mass, he is pulling this mass towards him. Now one force is from this side because he is applying, another force is in this direction, that is gravitational force, that is his weight. Okay, so by drawing like this, and it is the weight and it is the force what he is applying, then it will become like a free body diagram of a person, right? If you take person as a system, these are the forces. One is the gravitational force and another one is the muscular force, are the two forces acting on a person. Okay, that is right. So after completion of that, so that is called as free body diagram. So similarly, not only for person, for the mass also you can draw, for the mass also you can draw, right? So that only he is saying here. But these three steps you don't bother when you are going for problems. So then by applying so many times, it is easy to remember, right? Even though you memorize now, but when you are going to apply many times while solving the problems, it is very easy. Okay, right. So in this class we discussed two example problems related to our previous classes, and one important topic, the steps to be followed while solving the problems in mechanics. Okay, thank you.